Today we're going to talk about the process of succession in biology, and succession being a gradual directional change in a community over time until a stable climax community is established. And you can see that from the image here. You come from bare ground through a series of SERAL stages until you get the climax community, which is a mature woodland. There are two types of succession you need to be aware about: primary and secondary succession. Primary succession is a slower process. It starts with bare rock or sand, like a retreating glacier or a new sand dune forming, or a volcanic eruption here. A secondary succession starts with soil, but hardly any species. So, for example, following a forest fire. So, succession proceeds with a number of SERAL stages. So, this is shortened. But the bare ground, then you have pioneer community. They're colonising species that create the pioneer community. They're outcompeted by the secondary community, and they're outcompeted by the climax community, which is stable. So it's unlikely to change. It's really important to understand this concept. That at the beginning, for example, bare ground, really hostile environmental conditions. The pioneers are specially adapted to be able to cope with that. They'll change the habitat in such a way makes those hostile environment less hostile, and that is important because other organisms can now survive. That environment has been changed, and now new organisms can survive. So the pioneer species are kind of signalling their own demise by changing the environment, because they are now going to be outcompeted and they'll become extinct, possibly within that community. As you go from left to right, a number of different things will change. You're more likely to get more biodiversity and complex food webs as you go across here, the most being in the climax community. You're more likely to get more biomass. You're more likely to get more habitats and niches as you move across. And definitely the environmental conditions become less hostile. There are exceptions to this. In some situations you'll have the highest biodiversity somewhere in the middle in one of the secondary communities, but that's often not linked to a question. So what kind of characteristics might a pioneer species have? These link to quite a few of the concepts that you'll study about. So in the really hostile environmental conditions, there's no food about, so they're going to be a plant really, or be able to photosynthesize. They are more likely to be xerophytes because there's no soil for the roots to penetrate into. So they've got to have some way of preserving moisture, stop that water from evaporating. And there's no soil to get nitrates from, so they need some way of generating their own nitrogen. So they're more likely to have nitrogen-fixing bacteria associated with them in a mutualistic relationship. We're going to look at two examples. One is the glacial retreat. So when glaciers melt and retreat, they leave behind, you can see on the picture here, this muddy, rocky material. It's called a glacial moraine. So what's the pioneers going to be? Well, they're going to be mosses and lichens. You can see lichens here in the picture and some moss in the background. So these pioneer species, crucially you need to know, they modify, they change the habitat. And by existing there, living things will eventually die. And by dying, they're creating sort of layers of basic organic material and creating a very loose soil structure. And that's called humus. Not hummus, the dip, but humus spelt like that. So now we're adding layers to creating a very basic soil. That's allowing other species to move in and survive. So those new species that can come in and survive, they will outcompete the pioneers and they'll disappear. One example of a plant that will come in a secondary stage is a dryas plant. So they will further modify the environment to make it less hostile. The roots kind of hold the soil, the humus together. And so holding it together make it more easy for other plants to come in and not get blown away. Also, they've got nitrogen-fixing bacteria adding to the nitrogen content and nitrates to the soil. That's really important so that other plant species can start to make more proteins. After several other stages, you can get alder trees, and on alder woodland. As soon as you get trees colonising a habitat, especially deciduous trees, they shed their leaves. and these will decompose and add a lot of depth to the soil through more humus being formed. And eventually you get a spruce forest. So these trees are taller and will outcompete the alder trees. But it does take a long time, the whole process. Another example you might see is sand dune succession. Several SERAL stages, and you can see them outlined here. So here's where we get the pioneer species developing, a couple of secondary stages, and in the mature dune you've got your climax community, which would be trees. Depending on where in the country, it would depend on the type of tree. But again, the process is the same. You have pioneer species colonise, reduce the hostile environment by modifying the habitat, allowing other species to come and survive. They continue to modify the habitat, get outcompeted until you reach the climax community. So if you just have a quick think about this, then pause the video. Okay, so very close to the sea, you've got just pure sand. So any rainfall is going to go straight through. It's not going to be there available for the roots to absorb. Any moisture that's about is likely to be very salty, which, as you know about osmosis, makes it difficult for roots to absorb because the salty water's got a low water potential. Also, if you've ever been to the beach and sat on a sand dune, apart from the odd hot day, it often feels, because of the wind, it's very, very windy, and that will blow moisture away from the leaves, making it hard for them to conserve water. So just have a quick look at these two questions. Have a think, pause the video. So remember, a xerophyte is a type of plant species that's adapted to preserve or conserve water, reduce the evaporation of water from the leaves, reduce transpiration. So marram grass needs to develop these xerophytic adaptations, this pioneer species, to try and conserve water because of those hostile conditions we mentioned before. So if you just look at the marram grass, just have a look at how it's adapted. Pause the video. So you can see here we've got a rolled leaf that's going to trap moist air inside. That's going to lower the water potential gradient between inside the leaf and out, so there's going to be less evaporation of water. We've got these hairs also trapping moist air within the leaf for the same reason. And you've got a thick waxy layer on the outside that's going to reduce transpiration of water from the outside of the leaf. So in a succession question, I'll often give you data and you need to understand the framework for how to answer them. So this framework is really important. Firstly, you have to identify the pioneer species and use the data and show that increases first, and then it'll decrease as it's outcompeted. Then you've got to state how it could have changed the environment. But you've got to link it to the question. You can't just necessarily state it's going to add humus to the soil. Classic example was a question that was in a river. So humus had nothing to do with that in that question. So link it to the question. This should give you enough clues so you can know how it could have changed the habitat. So it changed the habitat to make it less hostile, and that allows new species to survive. Then you've got to state which species come in, so identify from the data what is the species that's going to come in, can now colonise those less hostile conditions, and can now outcompete the pioneers. And you can see at that point that the pioneers should start to decrease as well. And then finally, identify which organisms are in the climax community. So if you can now have a look at this data and pause the video and try and use the framework to answer the question. So you can see that beach grass has to be the pioneer because it increases and then decreases first. I think it's definitely the first to increase. You could quote the figures for when it starts to appear at about 25 years. That will then change the environmental conditions, make them less hostile. It might start adding humus to the soil. It might protect other plants from the wind by growing. So that makes the environmental conditions less hostile, so that the shrub bunch grass can now survive. This will then outcompete the pioneer species, and you can see that because this starts to increase after 50 years and the pioneer species start to decrease. And finally, identify what species are in the climax community, and you can see we've got hardwood trees and conifer trees represent the climax community. So you need to understand how you can manage succession. So first of all, what is conservation? So it's a dynamic process. So you've got to manage the resources that are already there, but you may also have to reclaim habitat. It might have been used, it might have become an urbanised area, or used for an industry or some other reason, farming, and you may need to reclaim that area to get it back to the original sort of habitat. Some really important reasons for conservation. We've got ethical reasons, we've got economic reasons, and also the cultural and aesthetic reasons. Linking conservation to succession, if we left all the habitats alone, they would eventually reach a climax community. And there are some really important and diverse habitats that exist within those sort of middle SERAL stages, the secondary stages. So sometimes you have to prevent succession from continuing to preserve and conserve species and that biodiversity. So if you follow the video link, this shows a really good example of how heathland succession can be prevented in that to maintain a high level of biodiversity. You may not agree with the financial reasons for doing it, but at least it illustrates how biodiversity can be preserved or conserved. There are also sustainable management of woodlands. And this video link shows examples of the benefits that coppicing can have to a woodland, and how this technique can increase biodiversity within the community.